Imagine a blazing giant so immense that if placed where our sun rests, our entire solar system would vanish. Not one planet at a time, but all at once, like dust pulled into the breath of an awakening celestial titan. Out there in the endless dark, such stars truly exist. Swollen hearts of fire that challenge every limit humanity has ever known. Share your thoughts below. If a single star could consume us whole, what force could have forged such power? And now, we open our first door. Why do stars exist that are large enough to swallow the entire solar system? Imagine drifting through a silent tide of starlight, moving slowly enough that even time seems to loosen its grip, when a question rises like a glowing ember in the dark. What would happen if a star so impossibly vast took the place of our sun? A star so large that the orbits of Mercury, Venus, Earth, and every distant world would dissolve inside its burning skin, swallowed not with violence, but with the slow, inescapable calm of a tide overtaking the shore. The thought alone feels like standing at the edge of an ancient ocean not meant for human eyes, a place where the scale of creation escapes our understanding, yet invites us closer all the same. Theoretical physicist Kip Thorne once remarked that nature's imagination is so much greater than ours, and nowhere is that more evident than in the bodies of fire we call stars. If a hypergiant occupied the position of our sun, the entire solar system would be transformed into a glowing memory suspended inside a cosmic furnace. Jupiter's orbit, a domain so distant that light needs nearly an hour to reach it, would rest comfortably inside the star's outer layers, and Saturn with its rings of ancient ice would drift like a grain of cold sand in the heat of a red, swollen atmosphere. There would be no Earth to bear witness, no moon to reflect a borrowed glow, only the quiet rearrangement of matter into plasma, into heat, into light. In truth, the solar system as we know it is fragile not because it is small, but because the universe still holds giants large enough to erase it without effort. What gives rise to such giants is a story woven into the earliest breaths of the cosmos. Stars are born from clouds of hydrogen that collapse under the weight of their own longing, gathering light the way a seed gathers water. But not all clouds are equal. Some are enriched with heavier elements. Some are colder. Some collide. And in these rare conditions, the embryo of a hypergiant begins to grow. These stars ignite with such ferocity that their surfaces cool and expand like mystical lanterns stretching against the dark. Astronomer Carl Sagan once reminded us that the cosmos is within us. And when I contemplate these giants, I cannot help but feel that they are expressions of the universe's yearning for magnificence. The difference in stellar sizes is not a simple ladder but a world of contrasts so dramatic that numbers stop feeling like numbers at all. On one end of the spectrum, tiny red dwarfs burn slowly, gently, with the patience of monks who expect to live trillions of years. On the other end, hypergiants flare like cosmic bonfires that may last only a few million years, yet shine with the brightness of entire clusters of lesser suns. Between these extremes lies a vast kingdom of stars, each with its own pulse, its own temperament, its own destiny. When I drift through this spectrum in thought, I feel as though I am wandering through a gallery of ancient deities, each sculpted by gravity and time. Some are small and steady, others are swollen and trembling, but all are shaped by the same laws that govern the atoms in our bodies. And yet, with all our instruments and insights, one question still eludes a simple answer. Which star is the largest? At first glance, it seems like something we should already know, like measuring the height of a mountain or the width of an ocean. But stars are not solid objects with edges we can touch. Their surfaces are not walls but shimmering gradients of gas, expanding and contracting like breathing creatures suspended in light. Their atmospheres ripple with storms larger than the space between Earth and the Moon, and their edges blur into the vacuum with a softness that defies precise boundaries. As astrophysicist Sara Seager once said, "The universe is under no obligation to make sense to us." And the stars seem to take this almost personally. The largest known hypergiants swell and shrink over time, their radii changing with temperature, magnetic storms, or eruptions that scatter their outer layers like rose petals cast into a river. Observing them feels less like studying a shape and more like witnessing a mood, a kind of stellar meditation where fire itself exhales and contracts in cycles beyond our lifespans. When scientists debate which star holds the title of largest, they are not arguing over measurements alone. They are wrestling with the limitations of human perception, with the way light dances before it reaches us, with the truth that even our most powerful telescopes must stare through dust, gas, and the distortions of space itself. As the years pass, new data arrives from observatories perched above the clouds, from spacecraft that drift beyond the touch of Earth, from interferometers that stitch distant beams of light into maps of trembling atmospheres. And each discovery reminds us that the identity of the largest star may change like the seasons, not because the stars evolve too quickly, but because our understanding does. It is a humbling thought, and perhaps a necessary one, for humility is the beginning of wonder. When I reflect on these questions, I feel a quiet truth unfolding beneath them. The stars are not merely objects of measurement. They are mirrors that reflect our longing to comprehend greatness, to understand beauty on a scale far beyond ourselves. They remind us that existence is not uniform, that the universe thrives on diversity, that the smallest red dwarf and the vastest hypergiant are both essential notes in the same cosmic melody. And if our sun seems modest beside these giants, it is only because we have momentarily forgotten that even modest stars can give birth to planets, to oceans, to life. I find a quiet lesson in this. A star need not be the largest to be meaningful, nor the brightest to be seen. In the same way, our significance is not measured by scale, but by the warmth we create, the gravity we hold, the light we share with those who orbit our lives. As astrophysicist Neil deGrasse Tyson said, "We are part of this universe, and the universe is in us." And that truth places every one of us gently among the stars. So when we ask what would happen if a colossal star replaced our sun, or why such giants exist, or how their sizes compare, or why the title of largest remains uncertain, we are not merely seeking facts. We are seeking our place in a cosmos vast enough to cradle both fire and thought. The questions pull us forward like constellations guiding ancient travelers, and the answers, shimmering yet elusive, invite us to listen with patience, with wonder, with the soft awareness that learning is itself a form of drifting through the stars. As we continue this voyage together, let us carry with us the understanding that the universe is not a cold expanse but a luminous tapestry woven from curiosity and time. And in that tapestry, every giant star, every tiny ember, and every question we whisper into the dark becomes part of a larger story still unfolding. Under the quiet breath of the cosmos, the question of how we measure a star becomes more than a matter of numbers. It becomes an invitation to understand the true scale of existence. Astronomers speak of solar radii as if they were simple units. But each solar radius is a memory of our sun's size. A familiar yardstick used to grasp the unfamiliar. A star's diameter stretches like a luminous horizon, and yet its immensity often hides secrets that no measurement can fully capture. The great astrophysicist Subramanian Chandrasekhar once remarked that the cosmos is a place where simple arithmetic breaks down. And nowhere is this more evident than in the way stars defy intuitive meaning. We look at a swollen red supergiant in the night sky, and instinctively assume that size must equal power. Yet the universe gently corrects us. A star's diameter does not reveal its mass, nor does brightness reveal its density. In the stillness of the interstellar dark, we learn that a star can be large but lightweight, luminous but fragile, immense but hollowed out by turbulent winds. As Carl Sagan once whispered to a generation of dreamers, the universe is not obliged to make sense to us. And indeed, the universe seems to prefer the poetry of paradox over the comfort of simplicity. Red supergiants and red hypergiants emerge like cosmic blossoms, each one swollen by time, burning through the last stages of nuclear fuel as if gasping for breath at the end of a long life. Their surfaces cool and deepen into crimson tones. Their atmospheres expand until the boundary between star and space begins to dissolve. A red supergiant is already immense, but a red hypergiant is something else entirely. A creature so vast that its outer layers drift away like mist. A star so extreme that even the laws governing it feel stretched thin. These are not stable suns, but swollen hearts beating irregularly in the final measures of cosmic time. The more we study them, the more we realize that their vastness is a consequence of weakness rather than strength. Their outer layers are not pressed tightly by gravity, but loosened, blown outward by internal storms and dying fusion cycles. Imagine a candle flame trembling in slow motion, its edges stretching and curling outward, unable to hold its own shape. That is how a hypergiant lives, its body unraveling into the void, shedding itself grain by grain, light year by light year. The physicist Kip Thorne once noted that a star in its final phase is less a solid object and more a dance of forces barely agreeing to stay together. And nowhere is that truer than in these trembling titans. When astronomers attempt to measure the size of such a star, they do not find a crisp boundary. No clean circle, no clear horizon. Instead, they meet a haze, a blurred region where plasma grows thin and the star's breath merges with interstellar winds. The point at which a star ends becomes almost philosophical. If its atmosphere stretches for billions of kilometers, if its gas flows into space like a tide, can we truly say where the star stops and the universe begins? This uncertainty is not a flaw of measurement, but a reminder of the fluid nature of stellar life. The cosmos paints with gradients, not with lines. In these shimmering giants, I find a quiet lesson that echoes beyond astrophysics. The largest stars in the universe are large precisely because they are near the end, swollen not by victory, but by exhaustion. In their fragile immensity, they teach us that greatness is not always a sign of power. Sometimes it is a sign of vulnerability. And like those vast stars, we too expand in strange ways when we near the edges of our limits. As the astronomer Annie Jump Cannon once wrote, "Stars are the eternal story of transformation. And in watching these giants, trembling and magnificent, we witness the universe rewriting itself in fire and silence. In the end, the blurred edges of a hypergiant's atmosphere remind us that even the brightest beings in the cosmos do not end abruptly. They fade gently into the night, becoming part of something larger than themselves. And perhaps that is the quiet truth the universe has been whispering all along. In the quiet distance of the constellation Cepheus, there breathes a star so deeply red that ancient astronomers called it the garnet of the skies. Mu Cephei glows with a color that feels almost alive, a molten crimson born from a surface cooled to the edge of collapse, where temperatures drop enough for titanium oxide to form and absorb the bluer wavelengths of light. The result is a hue so saturated, so mournful, that it seems less like the light of a star and more like the pulse of some enormous cosmic heart. I often think of what Carl Sagan once said: "We are made of star stuff." And when I look at Mu Cephei, I feel as though I'm witnessing that truth, not as poetry but as a living moment. If we carried this giant to our solar system and pinned it gently where the sun now stands, its vast, swollen body would stretch outward nearly to the orbit of Jupiter, engulfing Mercury, Venus, Earth, and Mars in a single silent bloom of red fire. Its diameter reaches roughly 1,420 times that of our own star, making the sun look like nothing more than a lantern placed beside a rising moon. Astronomer Roberta Humphreys once remarked that red supergiants are so extended that their atmospheres are only loosely bound by gravity. And with Mu Cephei you feel this looseness, not as theory but as imagery, as though light itself struggles to cling to its edges. Yet the garnet star is not steady. Its brightness waxes and wanes in slow cosmic breaths, rising and falling as pulsations ripple through its vast body like tides passing across a restless sea. This instability is a sign of a star nearing its final chapters. For such giants do not live long. They burn through their fuel with the desperation of beings aware their time is finite. As the core fuses heavier and heavier elements, the outer layers inflate and tremble, and the star becomes a lantern, trembling in the wind of its own mortality. I'm reminded of a line from Kip Thorne, who once said that the lives of massive stars are brief, brilliant tragedies. And Mu Cephei embodies that sentiment completely. Standing on some imagined world circling far beyond its reach, one could watch the garnet star flicker and swell like a dying ember in a fire pit that has seen too many nights, its light shifting in rhythm with an ancient clockwork we do not yet fully understand. That rhythmic dimming is not a flaw but a message, a reminder that all living things, even stars, carry their own patterns of breath, their own whispers of beginning and ending. Of all the signs that Mu Cephei is nearing its end, the most striking is the steady outflow of material, drifting away from it like ashes rising from a fading flame. Its stellar winds carrying future worlds in the making, carbon and oxygen, and heavier elements that someday may find their way into planets or perhaps into beings capable of standing under the night sky and wondering where it all began. Neil deGrasse Tyson often reminds us that the universe is under no obligation to make sense to you. Yet with stars like Mu Cephei, its story feels oddly familiar. It feels like watching an elder telling its final tale. As the star swells, it approaches a destiny already written in its core. A supernova whose light someday may wash across the Milky Way like a whisper of creation. A reminder that endings in the universe are not collapses but transformations. The garnet star will not simply vanish. It will give back everything it has made, seeding the galaxy with the elements of life. I find something comforting in that, a lesson tucked between the drifting layers of a dying star. that growth and collapse are not opposites but companions. That brilliance often comes just before silence. Perhaps the quiet wisdom of Mu Cephei is this, that even in its fading moments it remains beautiful, luminous, generous. And as we drift with it through this cosmic meditation, listening to the slow heartbeat of a giant nearing its rest, we are reminded how small we are, and yet how deeply connected to every ember that has ever burned in the dark. Imagine staring into the winter sky and finding a single red heartbeat glowing softly against the dark. A pulse so ancient it began before humans carved their first symbols into stone. That heartbeat is Betelgeuse, a star whose name travels across centuries like a whispered myth and whose presence has guided navigators, dreamers, and astronomers alike. It shines not with the calm steadiness of our sun, but with the trembling radiance of a giant nearing the end of its cosmic breath. As the astrophysicist Andrea Dupree once said, Betelgeuse is a star that lets us watch a death foretold. And perhaps that is why it holds us so tightly in its glow. Betelgeuse became famous long before modern telescopes, long before science wrapped the heavens in data and equations. Ancient skywatchers noticed its fiery hue and wondered what kind of being could hold such a color. For stars were not just points of light but living spirits that watched the world from above. Even today, our fascination remains the same, though we now cloak our wonder with scientific terms. We say Betelgeuse is a red supergiant, that it has swollen to nearly 1.4 billion kilometers in diameter, that its surface flickers with convection cells larger than entire planets. Yet beneath every technical description lies the quiet truth that humans have always known. Betelgeuse feels alive. Its fame deepened in 2019 and 2020 when a strange darkness passed over it, dimming its light by an unprecedented amount. For a brief moment, humanity collectively held its breath, as if an old friend had suddenly grown silent. Astronomers looked to their instruments, their models, their theories, asking whether this might be the moment we have awaited for generations. Could Betelgeuse be preparing to explode into a supernova, unleashing a wave of light bright enough to cast shadows on Earth at midnight? The astrophysicist Edward Ginnern said at the time, "I have never seen anything like this in 50 years of observing stars." And his words echoed the trembling curiosity of the entire scientific world. But the universe is patient, and Betelgeuse was not yet ready to die. The dimming was not a final cry, but a passing veil of dust cast from the star's own unstable surface, a whisper of its restless interior. When the dust thinned, its brightness returned, and scientists breathed again. Yet something had changed in us, because we had witnessed the fragility of a giant. We had seen the flicker of mortality in a star so enormous it could swallow the orbit of Jupiter. Something about that realization makes Betelgeuse feel strangely close, almost intimate. If Betelgeuse does go supernova in our lifetime, the spectacle would be unlike anything our species has ever seen. Astronomers say it would shine brighter than a full moon, visible even in the blue daylight sky. Its brilliance would wash over mountains and oceans, turning night into a soft red twilight for weeks on end. It would not harm us, for Betelgeuse lies 700 light-years away, but it would remind us of the forces that sculpt the universe. As Carl Sagan once wrote, "We are made of star stuff, and Betelgeuse may be the very kind of star that once seeded the elements of our own world." To witness its death would be to witness the beginning of countless future worlds yet unborn, and still. Despite its size and fame, Betelgeuse is nearing the end of its cosmic journey. A red supergiant can only burn so long before the weight of its own core becomes unbearable, triggering the outward explosion and inward collapse that end its life. Scientists estimate that Betelgeuse has about 100,000 years left, a blink of an eye measured against its millions of years of life. To the universe, this time is nothing. But to us, it is a vast and unreachable horizon. Humanity may not remember our own civilization's 100,000 years from now, but Betelgeuse's future supernova is already written in the quiet mathematics of stellar evolution. When we speak of Betelgeuse, we speak of impermanence, of beauty that swells before it breaks, of cycles greater than the rise and fall of species. Perhaps that is why its story resonates with so many of us, because in its flickering red light, we sense our own fragility reflected back. The star is old, ancient beyond any memory we possess, and yet it behaves with the trembling unpredictability of a living creature nearing the end of its strength. As if somewhere inside its turbulent heart, it knows it is running out of time. Watching Betelgeuse teaches us not just astronomy, but humility. It reminds us that even giants fall, even stars fade, even the cosmos itself changes in ways too slow for us to feel. And in that slowness, in that drifting of light across centuries, there is a kind of peace, a cosmic meditation that tells us everything is temporary but nothing is meaningless. If Betelgeuse were to vanish tonight, its light would still travel toward us for centuries, a final echo of a life lived in fire. In the quiet space between thoughts, when we step outside and look up at the winter sky, Betelgeuse becomes a companion rather than a curiosity. Its soft red glow feels like a lantern held in the darkness, guiding us not to answers, but to deeper questions. How many stars are nearing their final breath right now, unseen by any telescope? How many worlds have been born from the ashes of giants like Betelgeuse? And how many more will come after us? These are the thoughts that fill the long nights, the thoughts that turn astronomy into poetry. If you feel that quiet pull inside you, that curiosity that refuses to dim, then stay close on this journey with me. Let your thoughts drift like stardust and your wonder rise like a slow tide. And if this story touched you in some small way, whisper your thoughts in the comments below, because your voice becomes part of this cosmic conversation. And as we sail deeper into the mysteries of the universe, your likes and your presence help this little corner of starlight grow brighter. So breathe gently, look up once more, and let Betelgeuse guide you into the next chapter of our wandering among the stars, in the quiet drift of the cosmos, where starlight moves like ancient breath through a cathedral of darkness. Few celestial beings command as much awe as VV Cephei. It is not merely a star, but a swollen giant of fire whose very presence feels like a whispered reminder that the universe dreams far larger dreams than ours. Astronomers call it a hypergiant, a term reserved for the most extreme stellar titans whose atmospheres billow outward like veils of burning mist. Far larger and far more unstable than even the mightiest supergiants we know. As astrophysicist Roberta Humphreys once reflected, hypergiants are stars living on the very edge of what a star can be. And VV Cephei embodies that fragile boundary like a flame trembling in slow motion. To understand how a hypergiant differs from a supergiant, imagine a heart that beats too hard for its own body. a star so swollen that its outer layers are barely held by gravity. Supergiants are massive. Yes. But hypergiants are the ones that break the rules, whose atmospheres grow so thin and tremulous that the boundary between star and space becomes a drifting shore lost in its own tides. Their surfaces are cooler, their volumes many thousands of times that of the Sun, and their lives astonishingly brief because they burn through their nuclear fuel like poets tearing through the last pages of their own existence. The astronomer Stephen Smart once said, "The most massive stars burn fastest because they live like they are racing the universe itself." And VV Cephei burns with exactly that furious tenderness. Yet what makes VV Cephei even more haunting is the companion that orbits precariously beside it. A smaller, hotter star that tugs at its partner's vast and trembling atmosphere, drawing matter into a cosmic bridge between them. This is the secret engine of the system, the slow gravitational dance that turns stellar love into stellar cannibalism. Because VV Cephei is so enormous, its outer layers extend astonishingly far into space, and where gravity weakens, the companion pulls, forming a narrow stream of gas that spirals into a glowing accretion disk around the smaller star, a luminous whirlpool of matter turning in silence across millions of miles. An accretion disk is one of nature's most elegant mechanisms, a blend of gravity, angular momentum, and the soft violence of gas stripped from a dying giant. The stolen material heats as it falls, swirling into rings of fire like the ripples of a molten lake. To watch such a structure through telescopes is to witness creation and destruction braided together in a single fluid motion, as if the universe were painting with stardust and longing in the same stroke. VV Cephei, as atmosphere stretches so far that scientists struggle to say where the star truly ends. Because the star does not end. It fades, dissolving into layers of gas so extended that they almost touch the very surface of the companion star. Imagine a breath that reaches across worlds, a tide of fire drifting through the void, reaching for another sun like a hand longing for warmth. This proximity is why the system eclipses periodically, the hypergiant's vastness swallowing the smaller star's light, turning the entire region into a shadow play of dimming and brightening that reveals the scale of this cosmic pair. The more astronomers look at systems like VV Cephei, the more they realize how delicately the universe balances chaos and grace, how stars of impossible magnitude can exist only because every force holds its breath at the right moment. It is a reminder that gigantism in the cosmos is never simple, never easy, but always breathtaking. As Carl Sagan once murmured, the universe is not required to be perfect, but it is required to be beautiful. And few sights embody that truth more faithfully than a hypergiant bleeding light into a hungry companion. If you feel the gentle pull of wonder as we drift through these stellar giants, let your voice join this journey. Leave a comment, whisper your thoughts, and if this slow cosmic meditation brings you peace, let a like or a subscription be your way of sending a small signal back into the dark, reminding the algorithm and the universe that you are here. And as we drift onward, carried by the quiet glow of distant suns, remember that VV Cephei is only one chapter in a story far larger than itself. A reminder that even the greatest giants must one day give their light to another, and that every orbit, every eclipse, every whisper of gas between companions, tells us a little more about how the cosmos breathes. In the quiet half-light of the cosmos, there exists a star whose name drifts like a forgotten prayer across the archives of astronomy. Westerland 126 glows deep within one of the most crowded stellar sanctuaries in the Milky Way, a place where stars are born and die so close to one another that their light overlaps like candle flames trembling in the same breath of air. Some astronomers describe this cluster as a celestial city, a district of giants, and Westerland 126 stands among them not as a ruler, but as an elder whose body has begun to loosen, swell, and soften under the weight of its own burning heart. It sits there, wrapped in waves of red and gold that pulse like the final echo of a distant drum. Because this star is no quiet inhabitant of the night, it is a creature in the midst of transformation. Its size defies scale. Its atmosphere extends so far into the surrounding darkness that one begins to question where the star ends and where the universe begins. The astronomer Roberta Humphreys once said, "Hypergiants are nature's way of reminding us that the cosmos does not have to obey our sense of proportion." Westerland 126 embodies that reminder perfectly. What draws scientists to this particular titan is not only its size but the neighborhood it inhabits. The Westerland 1 cluster is one of the densest collections of massive stars in our galaxy, more than 10,000 times denser than the region around our Sun. Stars are squeezed together like ancient stones in an old temple wall, their gravity weaving invisible threads between them. It is in such an environment that giants like Westerland 126 grow, fed by the same cosmic cradle that once ignited them. Some astrophysicists propose that this density is not coincidence. It is a requirement, for only such intense nurseries can produce monsters of this magnitude. As we drift deeper into the heart of this stellar maze, we witness the slow unraveling of the star itself. Westerland 126 is losing mass at a rate that seems almost impossible. Every few years, it sheds a quantity of material equivalent to an entire Earth. Imagine for a moment an entire world's worth of rock, ocean, and atmosphere dissolving into space like mist from a fading dream. This mass loss is not a gentle breeze. It is a roaring stellar wind, a tide of particles so fierce that it shapes the nebula surrounding it. Theoretical physicist Kip Thorne once remarked, "Massive stars live violently because they must burn their lives high and fast to escape the gravity that created them." In Westerland 126, we see that violence turned into beauty. This shedding of mass signals something profound, something inevitable. The star is reaching the final movements of its cosmic symphony. Each pulse, each wave of expelled material, each luminous breath bringing it closer to the disaster that all giants eventually face. For stars of this size, collapse is not a distant myth. It is the final stanza of their existence. The question that haunts astronomers is whispered softly across observatories around the world. Will Westerland 126 explode as a supernova before it has the chance to collapse directly into a black hole? Some models suggest that its immense size and rapid mass loss make a supernova almost unavoidable, that the star will tear itself apart in a burst brighter than an entire galaxy. Others argue that the mass may fall inward too quickly, that the core will collapse silently, forming a black hole without the dramatic farewell we expect from such giants. Astronomer Stan Worsley once said, "The biggest stars walk a razor's edge between explosion and disappearance." And Westerland 126 may be walking that edge at this very moment. To watch this star is to watch time itself bending under the weight of inevitability. It is to witness the slow surrender of a being so vast that even its death may create new worlds. The dust and gas it expels could someday condense into planets, moons, comets, perhaps even life, in some far future. The universe is generous in that way, turning endings into beginnings with a quiet elegance that humbles anyone who pauses long enough to look. And as you listen to this drifting meditation, as we float together through the soft glow of this dissolving titan, I invite you to gently tap the like button or subscribe if the journey brings you peace. Not as a command, but as an offering to keep traveling with us through the hush of the stars. Let your thoughts ripple out in the comments. Tell me what you imagine when you think of a star shedding Earths into the dark. Do you picture destruction or creation? Do you see an ending, or the embryonic beginning of something yet unnamed? Slowly, gently, we return to Westerlund 126 and its uncertain fate, its glow wavering like the last ember of a fire built in ages long forgotten. No one can say with certainty whether it will explode in a supernova that shakes the silence of its star cluster, or fall inward into a gravitational abyss that no light can escape. Both paths are possible. Both are written into the physics of its dying heart. For now, all we can do is watch, wonder, and honor the fragile enormity of this being. As astrophysicist Carl Sagan whispered decades ago, we are made of star stuff. And perhaps in the distant future, the atoms drifting from Westerlund 126 will find their way into the bones of new worlds, new oceans, new listeners who will gaze up and ask the same ancient questions we ask tonight. So let us linger a little longer in the warmth of this fading colossus. Let us listen to the heartbeat of a star whose story is almost finished, but whose legacy may outshine its own final light. And as we drift onward through this cosmic tide, take a quiet breath with me, and stay with the journey. For the universe still has many giants to reveal, and many endings that shimmer softly into beginnings we cannot yet imagine. In the quiet reaches of the cosmos, where starlight drifts like ancient incense through a cathedral of darkness, Ky Cygni swells and sighs as one of the most enigmatic red hypergiants ever observed. It is not simply a star. It is a trembling world of fire. A slow-breathing titan whose edges blur into the void like a candle flame caught in a restless wind. Astronomers have tried for decades to measure its true size, stretching instruments and imagination to their limits. Yet Ky Cygni refuses to give them a clear answer. The problem is not ignorance, but volatility. Its atmosphere is a churning sea of plasma, rising and collapsing in titanic waves that obscure any clean boundary. As the American astronomer Edward Guinan once remarked when speaking about unstable hypergiants, you do not measure these stars so much as you negotiate with them. And Ky Cygni is a difficult negotiator. Its outer layers billow outward in vast convective cells larger than the orbit of Mars. Material lifts off its surface in shimmering sheets, then falls again like scarlet avalanches tumbling through a gravity softened by immensity. Each pulse, each tremor, each belch of gas redraws the star's outline in real time. Trying to mark its surface is like trying to sketch the shape of a cloud whose edges change with every heartbeat of the sky. This is why astronomers measuring Ky Cygni have produced results that drift across hundreds of solar radii, not because the instruments are flawed, but because the star itself is in constant transformation. As the astrophysicist Andrea Dupree once said of such giants, their atmospheres are not surfaces but storms. And Ky Cygni is exactly that, a storm of heat and matter, a wandering continent of star stuff suspended in darkness. What makes the mystery even deeper is the star's unexpected faintness. One would imagine that a hypergiant measuring more than 1,000 times the diameter of the Sun should blaze across our night sky like a ruby lantern. But Ky Cygni hides. Not because it lacks luminosity, but because distance, dust, and its own cool temperature cloak it in subtlety. Its light is dragged down the cosmic highway through clouds of interstellar dust in the Cygnus region, scattering and dimming until only telescopes can retrieve its glow. The star burns bright in reality, but dim in appearance, a paradox that has confused countless new observers and inspired many seasoned astronomers to look twice. There is also the simple truth that hypergiants are cool stars by stellar standards, their surfaces glowing not with blue intensity but with warm, deep crimson, a color that does not pierce the interstellar medium as efficiently as shorter wavelengths. Ky Cygni radiates with the gentle warmth of embers rather than the sharp blaze of flames, and the universe swallows embers easily. And yet, despite its quiet face in our sky, the star itself is anything but quiet. Inside it, nuclear furnaces rage across vast convective seas, building and breaking elements in cycles that echo across tens of millions of kilometers. Some researchers suggest that Ky Cygni may be drifting toward a late evolutionary stage, losing mass so rapidly that its remaining years are already numbered in cosmic terms. Its winds blow outward in massive waves, carrying away the star's story grain by grain, until one day it may collapse or tear itself apart in a supernova whose light could reach Earth long after we have forgotten the moment these words were written. Michio Kaku once said, "Stars are the engines of creation." But Ky Cygni reminds us that engines can misfire, overheat, and unravel in spectacular beauty. Its flickering boundary, its unstable breathing, its quiet appearance in our sky all combine to form a portrait of cosmic humility. For every giant shouting across the heavens, there is another whispering from behind veils of dust. The more we observe Ky Cygni, the more we sense that size in the universe is not power, not brilliance, but vulnerability. A star so vast it could swallow our Sun 1,000 times over, yet so fragile it can barely hold onto its own skin. In its trembling outline we see a reflection of our own impermanence, the truth that even the grandest structures are temporary. As our instruments sharpen, and new observatories like JWST and the extremely large telescope look its way, perhaps Ky Cygni will finally surrender a bit more of its shape, though never its mystery. For some stars, to be known fully is to cease being themselves. And so it breathes on, a drifting ember in a cold and ancient sea, inviting every curious soul to drift a little closer, and wonder why the universe built a creature that refuses to be measured. Out in the quiet reaches beyond our galaxy, in the soft shadow of the large Magellanic Cloud, there lies a star so swollen with fire that even the darkness seems to bow around it. G64 drifts like a lantern smothered under its own ashes, a hypergiant wrapped in veils of dust so thick they blur the line between star and night. And yet, through that haze, it pulses with a presence so immense that astronomers can only whisper its name with a mix of awe and uncertainty. In the words of astrophysicist Emily Levesque, stars like these are laboratories of the impossible, and G64 is perhaps the most haunting laboratory of all. When scientists first measured its size, they found a radius so wide that if G64 could somehow replace our Sun, its glowing edge would wash far beyond the orbit of Jupiter. It is one of the largest hypergiants known outside the Milky Way, a red titan whose outer layers drift like breath, too fragile to hold onto themselves. And yet, measuring such a creature is like trying to grasp the shape of smoke in a storm. Its surrounding cocoon of dust, thick as a cosmic fog, scatters light in every direction, hiding the true boundary of the star from even our most sensitive instruments. Astronomers describe it not as a surface, but as a suggestion, a trembling edge where starlight meets shadow and dissolves. The dust itself is a story of violence, because no star wraps itself so tightly unless it is tearing itself apart from within. G64 flings out gas and ash with winds so fierce they carve hollows in the surrounding space, creating a swirling envelope of its own discarded layers. In those currents, we glimpse the reason hypergiants are rare, and why they live so briefly. Their hearts burn too hot, too fast, consuming their fuel like a fire that refuses to simmer. As the great theorist Subrahmanyan Chandrasekhar once said, "A star's life is written in the mathematics of its flame," and G64 is a flame scribbling wildly toward its end. Its instability is not a flaw, but a destiny. The internal convulsions of such a massive star create pockets of turbulence, waves of heat and pressure that balloon its outer layers outward like a giant inhaling and exhaling in slow motion. At times, astronomers see it dim, not because it is fading, but because the dust cloud thickens, shifting like curtains around a dying fire. Other times, it brightens suddenly, as if the star has burst through its own chrysalis. Nothing about G64 is steady, and that is what makes it extraordinary. There is a quiet terror in the knowledge that this star sits on the edge of self-destruction, its vastness working against it. Gravity tries to hold its layers together, but the pressure from its core presses outward with relentless force, a cosmic tug-of-war that no star this large can win forever. One day, perhaps sooner in cosmic terms than we imagine, G64 will collapse or detonate, scattering its shroud of dust across the void like the final exhale of a giant. And in that moment, all the mystery of its bloated form, all the unanswered questions hidden behind the dust, will ignite into the brightness of a supernova. Yet for now, it remains suspended, a trembling colossus in a quiet corner of space. To gaze at G64 through our instruments is to look backward in time, to witness a star not as it is but as it was hundreds of thousands of years ago, flickering behind a veil. And perhaps that distance, that obscurity, is part of its allure. As Neil deGrasse Tyson reminds us, the universe is under no obligation to make sense to us, and nowhere is that more true than in the haze of G64. There is something almost meditative in contemplating such a star, something that slows the breath and widens the inner sky. For in its unsteadiness, we see our own impermanence mirrored. In its glow, we glimpse the quiet certainty that even giants fall. And as the dust drifts around it like forgotten memories, G64 teaches us that the universe is crafted not only from light, but from the shadows that hold it. So we drift with it a moment longer, letting the silence of the cosmos settle around us, knowing that somewhere beyond our galaxy, a hypergiant breathes its slow final breaths, waiting for the moment it will break its own darkness and scatter itself across the stars. In the quiet reaches of the cosmos, where light drifts like ancient incense through the dark, there exists a star so vast that even the mind hesitates before its enormity. RW Cephei, a molten giant suspended in the constellation of Cepheus, glows like a tired ember of creation. Yet in its fading breath it contains stories older than our species. Astronomers sometimes whisper that measuring a star is like trying to grasp the outline of a cloud. But RW Cephei is one of the rare giants whose size we can map with surprising confidence. Its luminous layers stretching outward until they become almost transparent. A sun so swollen that its radius reaches nearly 1,600 times that of our own star. Jim Kepler once said that to know a supergiant is to witness matter struggling against gravity's patience. And RW Cephei embodies that struggle in every trembling pulse of its surface. If one could pour light into a vessel large enough to hold this star's volume, it would take the equivalent of 5 billion suns to fill it. A comparison so extreme it drifts into dreamlike territory. And yet it is a true measurement born not from imagination but from interferometry, spectroscopy, and the patient stitching together of data across decades of observation. RW Cephei is not massive in the sense of a blue giant or a young and violent star. Instead, it is enormous because its outer layers have relaxed and cooled, expanding into a colossal sphere of glowing gas, where the boundary between surface and sky is a soft and trembling blur. Its volume is the result of age, gravity, and the quiet conflict between outward heat and inward collapse. A balance so delicate that even small changes in temperature ripple through its body like slow tides on an impossible ocean. Yet the true drama of RW Cephei lies not only in its size but in what it is losing. For this star is shedding its outer layers in streams of glowing material that drift into space like threads of gold torn from an ancient robe. Stellar winds roar from its surface at speeds that swallow any earthly comparison. And each year billions of tons of hydrogen and helium are blown away, as if the star is exhaling pieces of its own identity into the dark. Theoretical physicist Kip Thorne once remarked that a dying star is a lesson in letting go. And RW Cephei is letting go on a scale so vast that even metaphor feels small beside it. The winds that flow from it carve out shells of dust, sculpted by light and magnetic fields, forming a halo that grows more chaotic with every passing century. Astronomers believe these winds are signatures of the star's last struggle, for RW Cephei is no longer in the prime of its life. It is entering its final evolutionary stage, trembling at the edge of collapse. In stars like this, the core contracts as the outer layers expand. Fusion slows and rearranges, and eventually the internal balance breaks. The star will either shed enough mass to drift into a quieter fate or ignite its own undoing in a violent pulse that precedes supernova, though its exact destiny is still a gentle argument in the halls of astrophysics. As Carl Sagan once said, "We are watching the universe remember itself." And RW Cephei is one of those memories in the making. To observe this star is to watch time stretch and soften, to see a cosmic elder glowing through its final centuries, surrounded by the fragments of its own unraveling. Even now, its light touches Earth after a journey of thousands of years, carrying with it whispers of its slow decline, its vastness, its dignity. We study it not only to measure a giant, but to understand our own sun's far future. For in its swollen glow lies a quiet prophecy of what stars must eventually become. And so, RW Cephei drifts across the dark like a lantern dimming in slow motion. Enormous, fragile, majestic in its surrender. Watching it is like listening to the universe breathe. Each pulse a reminder that even the largest of stars are temporary. In its shimmering decay, it teaches us something profound about endings, about beauty, about how even in collapse, there is light that refuses to vanish. Scuti rises in the cosmic dark like a silent lantern of impossible scale, a trembling red giant whose light seems to breathe with the slow rhythm of the universe itself. Astronomers once whispered its name with the same awe one reserves for mythic beasts, because for a time it held the staggering title of the largest star humanity had ever measured. In those early observations, when instruments struggled to peel back the drifting veils of gas around its form, Scuti appeared to stretch outward in every direction like a celestial blossom frozen in the act of opening. Nature is far more imaginative than we are, Carl Sagan once said, and Scuti became one of the clearest proofs of that truth. To understand why it was once crowned the largest star is to understand the difficulty of measuring something whose very edges refuse to be still. Red hypergiants like Scuti are not neat spheres but turbulent oceans of plasma, rippling with storms so vast that Earth would vanish inside a single rising wave. When astronomers first studied it, the star's enormous and shifting atmosphere caused its radius to appear almost unimaginable, an expanding world of fire that could swallow the orbits of Mercury, Venus, Earth, Mars, and even Jupiter in its embrace. The title did not come from certainty but from astonishment, a recognition that we had found something so titanic that our measurements trembled beside it. Then came the phrase that still lingers in scientific lore: 13 seconds of light. It seems simple, almost delicate, like a line of cosmic poetry rather than a physical measurement. But hidden within it is a scale that bends the mind. For if one could travel at the ultimate limit of speed, the speed of light itself, it would take 13 full seconds to go from Scuti's blazing core to the trembling edge of its surface. Nothing in our daily lives prepares us for that. Not the distances we walk, not the continents we cross, not even the orbit of Earth around the Sun. 13 seconds becomes a meditation on the sheer extravagance of the cosmos, a reminder that stars can grow into realms rather than objects. If we placed our solar system inside Scuti, we would vanish inside its breath. The orbit of Earth would dissolve into its inner layers, warm sparks swallowed in a sea of churning helium and oxygen. Mars, a pale ember under its radiant glow. Jupiter, the giant we know so well, would drift like a lonely moon beneath the star's swollen atmosphere. Only Saturn might hover near the outer reaches, its rings shimmering like a fragile halo at the boundary between light and nothingness. When you grasp the scale of such a star, astrophysicist Michel Fowler once noted, you realize how small even our grandest cosmic landmarks truly are. Scuti turns the solar system into a miniature model, a whisper inside a roar. Yet, for all its grandeur, Scuti is a mystery that unsettles the very models used to explain the lives of stars. According to stellar evolution theory, stars of such size should not exist for long, nor should they retain stable atmospheres, nor should they reach radii so immense without collapsing under their own gravity. The equations insist on boundaries, limits, natural ceilings to prevent such cosmic excess. And yet, here Scuti stands, a quiet rebellion glowing in the dark. Part of the difficulty lies in the star's turbulent outer layers. where convection cells rise and fall like continents of fire. Each cell may stretch millions of kilometers across, creating a surface so chaotic that defining the edge of the star becomes more a matter of philosophy than physics. Astronomer Roberta Humphreys once remarked, "These hypergiants rewrite their own boundaries as quickly as we try to measure them." The star expands, contracts, pulses, shedding mass in titanic breaths that challenge the stability of every model we use to predict stellar lifespans. Even more perplexing is the way UY Scuti radiates energy, for its luminosity suggests internal processes that are difficult to reconcile with its apparent volume. If the star is as large as it once appeared, its density becomes impossibly low, a cosmic soap bubble of unimaginable scale. How does such a structure remain whole? How does gravity hold it together? How does nuclear fusion at its core communicate with a surface 13 seconds of light away? These questions drift through astrophysics like soft constellations awaiting connection. And so UY Scuti becomes more than a giant. It becomes an invitation. A reminder that the universe is not obligated to fit neatly within our predictions. That nature builds wonders that defy our diagrams. And that sometimes the largest truths flicker at the edges of our uncertainty. Later studies refined its size, adjusting its radius downward, lifting the crown of largest star from its shoulders. Yet the legend remains. Not because of measurement, but because UY Scuti offered a glimpse into how wild, how extravagant, how wonderfully unpredictable the cosmos can be. Larger stars may have since claimed the title, yet UY Scuti continues to pulse in the quiet reaches of Scutum, a slow heartbeat echoing through regions of dust and drifting hydrogen. Future telescopes may look at it and tell us something new, something that reshapes our understanding once again. But for now, its story flows like a river of fire across the night. In this drifting space between knowledge and wonder, UY Scuti asks us to pause, breathe, and remember that every measurement we take is also a moment of humility. The universe is a patient teacher, revealing its truths slowly, in pulses, in whispers, in stars so large that light itself needs 13 seconds to cross them. And as we drift through this cosmic meditation, we feel ourselves becoming small in the most comforting way, held gently in a universe that is far older, far stranger, and far more beautiful than we can ever imagine. Under the quiet canopy of the cosmos, VY Canis Majoris burns like a restless spirit refusing to sleep. It is a red hypergiant so vast that our sun becomes a trembling spark beside it. And yet size is not what makes this star unforgettable. Its true legacy lies in its violent exhalations. Those cosmic eruptions that tear pieces of itself away and fling them into the dark like fragments of a heart beating too fiercely for its own survival. Astronomers have watched these outbursts with both awe and unease, seeing in them the signatures of a star living at the brink. The astrophysicist Roberta Humphreys once said that VY Canis Majoris is one of the most extreme stellar objects we know, a reminder that the universe still holds places where physics stretches toward breaking points. These eruptions are not gentle breaths. They are convulsions, explosive waves of gas and dust hurled across trillions of kilometers. They begin deep within the star's turbulent interior, where convection cells the size of planets churn like boiling seas. When these currents rise, they can push entire layers of the star outward, loosening the grip of gravity and allowing matter to escape in colossal plumes. To observe such an event is to witness a star shedding its own skin, trying desperately to stabilize a body that no longer listens to itself. The astrophysicist Keiichi Onaka once noted that the surfaces of these hypergiants are storms beyond our imagination. And when you study VY Canis Majoris, you understand that he was speaking with terrifying accuracy. There is a melancholy beauty in the way this star deteriorates, as if every eruption were both a scream and a prayer. The dust clouds it has expelled hang around it like ghostly petals, forming a nebula stitched together from the remains of its own past selves. Each plume is a memory, a moment where the star tried to hold on and failed. And yet, these failures are precisely what allow scientists to study its nature, because the patterns etched into these ejected shells reveal the turmoil beneath the surface. One shell shows 1,000 years of instability. Another marks a century of violent pulsation. And together they paint the portrait of a giant struggling against an inevitable fate. What makes VY Canis Majoris so unstable is the delicate balance between its immense mass and its failing internal pressure. It is old, ancient by the measure of massive stars, and its nuclear furnace is sputtering deep within its core. The reactions that once kept it stable grow inconsistent, allowing gravity to tighten its grip in some regions, while others swell outward uncontrollably. This uneven tension sends ripples through its atmosphere, cracks in the cosmic facade that widen until they erupt, leaving scars that drift into interstellar space. The physicist Stan Owocki once remarked that massive stars die loudly, and when you look at VY Canis Majoris, you see a star rehearsing its final cry again and again. There are moments when scientists question how such a star can even remain coherent. Its atmosphere stretched thin, its gravitational embrace weakening, its energy leaking away through every eruption. And yet, it continues, as if some quiet resilience keeps it suspended on the edge of collapse. Every photon that escapes from its surface carries with it the story of a star that refuses to surrender, drifting across space to remind us that even dying giants shine with dignity. Observations from powerful telescopes reveal arcs of dust rippling outward, relics of ancient eruptions that illuminate the path this star has taken through its life of turmoil. They show us that instability is not chaos, but a long conversation between gravity and light. When we contemplate its future, we find ourselves standing at the threshold of cosmic inevitability. In human terms, the star may last another 100,000 years, but in the language of the universe, that is merely a breath. At any moment in astronomical time, its core could fail, its structure could cave inward, and a supernova would waken the surrounding dark like a sunrise carved from fire. This is the destiny waiting for VY Canis Majoris, a fate woven into its very being. And yet it continues to resist, pulsing, erupting, telling its story in waves of gas and dust that ripple outward like chapters in a cosmic diary. To study such a star is to feel both small and profoundly connected, as if its instability mirrors our own fleeting place in time. Carl Sagan once wrote that we are star stuff, and nowhere is that truth more literal than here, in the presence of a giant unraveling across the ages. The elements screamed into existence when VY Canis Majoris finally collapses will seed future worlds, future suns, future stories. Its death will be a creation, a reminder that even in destruction the universe continues to build. And so we drift alongside it in thought, breathing in the rhythm of a colossus on the edge, watched by telescopes, honored by science, and feared in its grandeur. VY Canis Majoris teaches us that the universe is not calm, not stable, but a tapestry woven from storms and silence alike. And if we listen closely, beneath the eruptions and the roaring winds, there is a deeper message: that even the mightiest giants tremble, that even stars can lose their light, and that impermanence is written into the heart of everything that shines. Under the quiet glow of distant dust, Stevenson 218 rises like a crimson lantern suspended in the deep night. A star so vast that even imagination struggles to hold its shape. For decades, astronomers have whispered its name with a mixture of awe and caution, calling it perhaps the largest star humanity has ever measured. Its radius stretches more than 2,000 times that of our Sun, an enormity that turns the solar system into a child's toy scattered at its feet. The astrophysicist Roberta Humphreys once said that hypergiants are laboratories of stellar extremes, and Stevenson 218 is the most extravagant laboratory of them all. To understand why it wears the crown of cosmic magnitude, one must drift into the heart of its swollen atmosphere, a sea of gas so extended that the concept of surface becomes almost meaningless. The star has bloated under the final pressures of nuclear exhaustion, its layers pushed outward like the slow exhale of a dying giant, forming a globe so huge that light itself takes long breaths to travel from its center to the edge. In a universe where scale often betrays intuition, this star stands as an outlier, a testament to what happens when matter and time push themselves to their last thresholds. And yet, for all that immensity, the gravity at its surface is softer than one might expect. It is one of the paradoxes that makes Stevenson 218 so mesmerizing. Its mass immense yet spread across a volume so colossal that its outer layers drift in a kind of cosmic looseness, like the edge of a fog bank rather than the surface of a sphere. Theoretical physicist Kip Thorne once remarked that gravity is the subtle sculptor of the cosmos. And here gravity sculpts gently, barely holding on to the gas that eternally strains to escape. These soft edges allow the star to shed its material in slow, constant streams, the way smoke bleeds away from embers in the dark. That lost material forms a vast nebular shroud around the star, a veil woven from centuries of stellar breath, drifting outward in loops and ripples as if the star were unraveling itself thread by glowing thread. Astronomers peer through that veil and see evidence of intense mass loss, a process so powerful it can reshape the space around it, building a cocoon of dust and gas that dims the star's own light. In the words of astrophysicist Emily Levesque, hypergiants are shedding their identities in real time, and Stevenson 218 is doing so at a rate that almost defies comprehension. Millions of Earth's worth of material flowing into the void with every passing century. In that quiet disintegration lies the truth of its future. For a star this enormous cannot linger in the universe for long. Its fuel burns not in decades but in pulses of cosmic urgency. A few 100,000 years is all that remains for this titan, a mere sigh in the lifespan of the galaxy, before it must collapse or explode in a final act of stellar surrender. The bigger the star, the shorter the life, astrophysicist Neil deGrasse Tyson often reminds us, and nowhere is that more tragically poetic than here. The greater its brilliance, the faster it races toward its own undoing. As we drift backward from this red colossus, we feel the strange tenderness of its existence. A star too vast to survive, too bright to endure. Its story is a meditation on impermanence, on the quiet truth that even giants made of fire must one day fall into silence. Perhaps that is the lesson Stevenson 218 leaves us. that scale does not grant immortality, that even the grandest lights fade. Yet, in their fading, they give us the nebulae that seed new stars, new worlds, new beginnings. And so we watch it from afar, drifting slowly in the velvet dark, knowing we are witnessing a rare moment in cosmic history, the final great breath of the largest star we have ever found. In its glow, quiet and trembling, the universe reminds us how brief and how beautiful even its mightiest creations can be. Among the titans we have wandered through, there is always one star that lingers a little longer in the mind. A giant so vast that its very existence feels like a secret whispered by the universe itself. Some people speak of Uy Scuti as the great astonishment. Others find themselves haunted gently by the trembling red glow of Vy Canis Majoris. Yet for many astronomers the true marvel is Stephenson 218, a star so swollen with fire that its breath alone could cradle our solar system within it like a pearl lost inside a burning sea. When we ask which star is the most surprising, we are really asking which boundary of imagination we are willing to cross, because each of these giants invites us to step over the threshold of what we once believed possible. As Carl Sagan once said, the universe will always exceed our wildest dreams, for it is not obliged to follow the limits of imagination. The lives of these stars, enormous and unsteady, illuminate more than the distant reaches of space. They reveal the fragile choreography of stellar evolution. Red supergiants and hypergiants are not simply big. They are old hearts, nearing the final beats of their cosmic rhythm, their outer layers swelling and trembling as gravity and fusion struggle for balance. A dance that ends in collapse and rebirth through supernovae. Every pulse of their surfaces, every shimmering ripple in their atmospheres, is a record of the universe remembering itself through cycles of creation and destruction. As astrophysicist Kip Thorne once reflected, to watch a star die is to witness the universe writing its autobiography. And so we look to these giants not just for their size, but for the wisdom woven into their final burning chapters. The lessons they offer slip into our understanding like quiet comets gliding across a still horizon, reminding us that stars live long lives of tension and release, that expansion is often the prelude to transformation, and that even the brightest are destined to fall inward and ignite the space around them with new possibilities. In their slow dying breaths, we see the future of our own sun, a reminder that nothing in the cosmos is static. That change is the only inheritance written into the very fabric of starlight. It is natural then to wonder whether the stars we know today are the largest the universe has to offer, or if greater behemoths hide in the veiled corners of the galaxy waiting for our instruments to sharpen. Technology has always played the quiet role of revealer, lifting one curtain after another as our eyes evolve with our tools. Telescopes of the next generation, like the extremely large telescope and advancements in interferometry, promise to peel back layers of dust and distance that once kept entire stellar families hidden from view. And as astronomer Sarah Seeger once remarked, every time we build a better window into the cosmos, the universe shows us something it was keeping just out of sight. There is a peaceful thrill in knowing that even now, there may be giants larger than Stephenson 218, breathing softly somewhere behind clouds of cosmic dust, their light stretched thin across the darkness, waiting for us to find them. Perhaps future surveys will reveal stars whose atmospheres billow out like wandering nebulae, or hypergiants so immense that the scale itself feels like a dream left unspoken. The more we learn, the more tender our ignorance becomes. for we understand at last that the universe is not finished surprising us. In drifting through the stories of these colossal suns, we drift also through the history of everything that has ever burned in the dark, touching the edges of knowledge like fingertips brushing calm water. And as we move deeper into this journey, guided by starlight and quiet curiosity, we carry with us the enduring truth spoken by Neil deGrasse Tyson. The universe is under no obligation to make sense to you. Yet even in this great unobligation, it offers us beauty, wonder, and the soft promise that the more we look up, the more the sky will reveal.